Hello, this is a tutorial sheet to give you practice on using sum and product method to factor quadratic equations where leading coefficient a is 1. So you'll recall the quadratic equation is like ax squared plus bx plus c. So we are trying to find two numbers whose product is c and whose sum is b. So I have written this in that form: x squared plus p and q. P plus q are the two numbers, p and q are the two numbers whose sum is b and whose product is c. Once we find these two numbers, we can factor it in the form x plus p times x plus q. Okay, so let's practice. Here we have first equation, x squared plus 5x plus 6. So what is the idea? Idea is to find two numbers, p and q, whose product is 6. So when you multiply, you should get 6. So we have p times q equals to 6. Second thing, what do you want? We want p plus q equals to 5. So these are the two numbers we are looking for. So, well, there are only few factors of 6. You can try. 1 times 6 add to 7, not 5. 2 times 3 is perfect. So we can split this into 2 and 3. 2 times 3 is 6, and when you add 2 and 3, you get 5. In that case, we can split 5 and write in terms of 2 and 3. So we'll do that. X squared plus 2x plus 3x plus 6. Once we do that, then we can factor out common factors like this. Combine these two terms. So in the first set, we have x as a common factor. I can write this as x times x plus 2. And here, what is the common factor? 3. So this will be 3 times x plus 2. Remember, we are doing in a fashion so that we get again a common factor. So he got x plus 2, correct? So this could be written as, so you can factor out x plus 2 now. Once you do that, you get x plus 2 times x from here, and 3 is left here, correct? 3. So we got the factors of x squared plus 5x plus 6. You will note that the numbers 2 and 3 are same as our p and q, which we started with. So instead of going through these two steps, we could have written our answer directly, correct? Next time, I'll write my answer directly. What you can do is expand and check whether you get the same thing or not, correct? Let's try this one. So p times q should be how much? 15. And p plus q should be how much? Minus 8. Well, if you want 15 plus 15 as the product, then the sign of both the numbers should be same, either both minus or both plus. But since when we add we get minus, then the two numbers are negative. Is that okay? So let's try factors of 15, 3 and 5. So simple. So we can write this as 3 and 5. When you times minus 3 with minus 5, what do you get? Plus 15. Or when you add minus 3 and minus 5, what do you get? Minus 8. Therefore, I can straight away write x squared minus 8x plus 15 as what? X minus 3 times x minus 5. That should be good. Now, we need to check. Is it really correct? We avoided those two steps. Will it work? Let's check it. Okay. X times x is x squared. And this is minus 5x. So I'm multiplying this with both, correct? And then minus 3x. When you multiply with 3, minus 3 times minus 5 is plus 15. And this is equal to x squared minus 8x 15 plus 15. Do you see? We get the same result. Perfect. It works. And it will work all the time. Let me do one more with you, okay? This time again, what is p times q? Minus 7. And what should be P plus Q? Yes, P plus Q is how much? Minus 6. This time we are looking for two numbers whose product is negative. So their signs have to be opposite. And when you add them, you get negative. That means the bigger number is negative. So this sign is actually of the magnitude bigger number. Okay. Now, what numbers can give you product of minus 7? 7 is a prime number, so simple as that. So the numbers are 7 and 1. Both cannot be positive because we need negative. Which one is negative? Larger of the two, because we need minus 6 when we add. So we can write this as a factor of x minus 7 times x plus 1. Multiply these two to check whether this is right factoring or not. Okay, so this is a very simple and effective way of factoring trinomials. These are trinomials, right? Because they have three terms where the coefficient of x square is 1. A is 1. Okay, now you must have noticed one thing, that every trinomial cannot be factored, right? So here's a question for you. Write a trinomial that cannot be factored. Explain your thinking. Well, you can write one from here itself. You know, 7 is a prime number, so it has only two factors, 1 and 7. So what are the possible values of this x middle term? It could be, if I have both as negative, then minus 8, both positive, plus 8. One negative, one positive, then we could get minus 6 or plus 6, correct? Those are the only possible equations. But think about this. If I write x square plus 5x plus 7, can I factor it? No, I can't. Because to get 7, we can multiply only 7 times 1. When you add 7 and 1, you'll get 8, not 5. So there are no factors of 7 which when added will give you sum as this. So this cannot be factored. Likewise, you can have many, right? So this is to show you that all trinomials cannot be factored. Therefore, in some questions, you will get factor the following trinomials and verify your results. Factor fully if possible. Let me add the term, if possible. Because at times it may not be possible to factor your terms. Okay, so keep that in mind. Here are a few questions for you to practice. Correct? So make a copy of these questions and then try them out. Okay, these are very simple, but it will give you very good practice. Here we have two questions which are kind of thinking and communication problems. Okay, let's concentrate on these two questions for the time being. Explain why the trinomial x square plus 4x plus 21 cannot be factored. I just answered your question, right? So you have to look for all the factors of 21. Like 3 times 7 is 21, 1 times 21 is 21. Add them. Can you get 4? If you can't get 4, then you cannot factor it. Correct? That's how you have to explain. Now, the last question, question number 6 is, find all possible values of k for which trinomial x square plus kx plus 6 can be factored. So k can have many different values. For example, you need product as 6. Factors of 6 are 1 times 6. When you add them, you get 7. So k could be 7. Another set could be 2 times 3 is 6. When you add them, 2 times 3, 2 plus 3 is 5. So this could be 5. You need plus 6, right? You could use both negative numbers. So negative 1 times negative 6 will give you plus 6. And k value will be minus 7, right? Similarly, minus 3 times minus 2 is 6. And k could be minus 5. So these are the different ways you can figure out what the possible values of k are. I hope you find it interesting and get some hands-on practice. Solve these problems on your own and see if you can factor them. Okay? Have a good look at it. Thank you.